Hi dear students, welcome to my channel. This is IIT JEE Advanced 2025 Paper 1 Physics Solution. This is question number 5. This is x-axis, y-axis, z-axis. Y greater than or equal to 0 magnetic field exists along the direction of z-axis. Here one conducting loop is there, square loop. This square loop is entering into this magnetic field with velocity v0. This conducting loop mass is given capital M and resistance of the conducting loop is R. At t equals 0 it enters into the magnetic field region. And one more information is given, one constant k equal to b0 square L square by R into M. First we will understand, when this loop is entering into this magnetic field, the magnetic flux through this loop will keep on increasing. Along which direction? Along z direction. Because magnetic field is there along z direction, the magnetic flux is increasing along the z direction in this loop. So when it enters inside this magnetic field, because of change in magnetic flux with the time within the loop, there will be EMF induced in the loop. First we have to calculate what is the induced EMF in the loop. You see, the loop is entering like this along the y direction in the xy plane. This is the length L, breadth also L because it is a square loop. This length L completely entered, this edge is entered into the magnetic field. But this part only first entering is here. This breadth is entering from here. So this is length L, some part of it entered into the magnetic field inside. It is a variable. It is a variable. So the flux through the area, how much it entered, suppose it entered some distance like this, so this will be the area. So area from here to here like this, will be the area. So when it enters here, somewhere here, it has traveled a distance of y. Because it is y direction, I am calling it is y. This y into L, that is the area. The flux is equal to magnetic field into area. That area is L into y. Okay. So along this direction, approximately some distance it has traveled. Some distance it has traveled. I am calling this is y. This is y. Then this area within this portion area is L into y. So phi is equal to B into L into y. It is not constant. Why? Because this loop is moving. So this y is varying, the flux varies. E is equal to minus d phi by dt. This formula we know. Induced EMF is equal to minus d phi by dt. So minus dl dy by dt. dy by dt is velocity of the loop along the y direction. So that I can write v. So induced EMF equal to, I am getting minus BLV, take magnitude, that is BLV, then current induced, because of EMF is there, current will be there, I is equal to E by R, that is BLV divided by R. Okay. Now the current is induced and it is flowing in the loop, and it is also inside the magnetic field. There will be magnetic force on the loop. First you should understand what is the direction of this induced current. When it enters or entering into the magnetic field, the magnetic flux along z direction is keep on increasing. Okay. As per the Lenz's law, the induced current such that it will oppose the change What is the change here? Magnetic flux is increasing along z direction. It should oppose. The induced current also produces the magnetic field. It should be opposite direction to this B. So the induced current has to flow like this. Like this. Okay, because the flux is increasing along this direction. The flux should decrease along this direction. That's why if current is flowing like this, no, because of induced current, the magnetic field is downward here inside the loop. So it is opposing. So you can now understand that this is the direction of the current. For me it is clockwise direction. F is equal to BIL, magnetic force. F equal to I into L cross B. So F equal to BIL I am taking. L and B both are perpendicular to each other. So BIL I am taking. For direction, what you have to see, when it enters into the magnetic field, the magnetic force opposes its motion. I into L cross B. This is I direction, means L direction. L cross B. L cross B. L cross B, the force direction will be opposite, along this direction. The motion of the loop is along positive y direction. The magnetic force will be negative y direction. So the velocity of the loop direction is positive y direction, and the force exerted due to the magnetic field is minus y direction. That is why it is minus. Here F is equal to minus, I wrote here, minus BIL actually. BI is equal to already just before you have derived, that is BLV by R. So you will get minus B square L square V by R. From Newton's second law, force is equal to M into A, that you know. That is equal to minus B square L square V by R. Then A is equal to minus B square L square divided by MR into V. This is the constant given, that is K. So A equal to minus KB. The velocity direction is opposite to the acceleration. It is opposing the motion. That's why it is minus. Already I told, I am repeating. So A is equal to dV by dt equal to minus kV. Do simple integration. Initial speed is V0. After some time velocity changes. So final limit is V. This is simple. What you will get? V is equal to V0 into e power minus kt. Means velocity of the loop is decreasing exponentially. Further we will do how displacement is varying along the y direction. V is equal to dy by dt because it is moving along y direction. So I am substituting here. I am doing again integration. I will get an equation like this. At times 0 time it is just entering, y is 0. After some time t, some y is there. So that is why I got the equation like this. Simple integration, that you know, the y is equal to V0 by k into in the bracket 1 minus e power minus kt. We got these two equations. One is V is equal to V0 into e power minus kt. Y is equal to V0 divided by k into 1 minus e power minus kt. Now what are the options given? Now we will read the options. By seeing these two equations, we can answer this. First option, what they asked, if V not equal to 1.5 into KL, loop will stop before it enters completely inside the region of magnetic field. This is the wrong option because the velocity of the loop is decreasing exponentially. It will become rest at infinite time, but loop length is finite length. Certainly, the loop will not come to rest after just traveling a length of L. What is L? L is the loop length. So it is just traveling a distance of the length of this loop up to from here to here. It will not come to rest. This is wrong option. Now option B. When the complete loop is inside the region. Now loop completely entered into the region of the magnetic field. The net force acting on the loop is 0. This is correct option. Option B is correct. When it is completely inside, the magnetic flux will not change with time. Then induced EMF is 0. Then induced current is 0. Then force also 0. That is why net force acting on the loop is 0 given. So option B is correct. Now option C. Option C is asked like this. If V0 is equal to KL by 10, the loop comes to rest at time t equal to 1 by k ln 5 by 2. Option C is wrong. Because the velocity will be 0 at infinite time. Not a particular time. So option C is eliminated. Now option D. If V0 equal to 3KL. This is the option D we have to calculate. If V0 equal to 3KL, the loop will enter completely into the magnetic field in a time t equal to 1 by k ln 3 by 2. Whether it is correct or wrong, we have to do it. So V0 equal to 3KL, you can substitute here because this is the expression for displacement of the loop inside the magnetic field. So here V0 is given, that is 3KL. It has traveled y equal to L. Completely inside matlab y equal to L. Then time t we have to calculate. You substitute y is how much? L. L I am putting. V0 is 3KL. 3KL I am putting. Divided by k. So 1 minus e power minus kt. So this you can substitute. LL cancel, KK cancels. Simplification. This is very easy. That you can do it. 1 by 3 is equal to 1 minus e power minus kt. And this is a simplification. I did not do. Explain your IIT aspirant. This you can do it. So after this you are getting the time t is equal to 1 by k into ln 3 by 2. So this option D is correct. So for this question, two options, option B and option D, both are correct. I hope you understood. Please like this video, share this video and subscribe my channel for further upload of my videos related to IIT Advanced Solutions of Physics. Thank you students. Bye bye till next video.